Bluetooth from connections. It's just nature what in
Continue, sir. You are audible.
Yes, thank you. Good morning, all of you. Dear Spox across India, I hope all the results Spox that have listened to those who are participating in this hackathon final. Please see that all the participants along with this Spox should join this important yeah, boot camp 3. It is in a series, it is a boot camp 3. And today is going to be very important because honorable chairmen are also going to release your participation certificates to the participants who have participated in the three boot camps. So in this connection, I request all the Spox, particularly the finalist Spox, um, please arrange this live session in your uh, classroom or your auditorium. Don't share this link to the students directly because we will face very severe problem in controlling these students. So please arrange in your hall, in your seminar hall or your computer lab, and please see that every student should have their own laptop fully charged and also have the network. Please see that there should not be any network issue. Today, it's a kind of motivation as well as an orientation. Final hackathon. Yesterday, Honorable Chairman spoke to Honorable HRD ministers in our Rakesh Garu. And immediately after Pongal, actually they wanted to conduct during the Pongal vacation, but we requested them that as most of our colleges are in Pongal vacation, those students in the faculty not available. I requested to conduct this final hackathon after 20th of January this month. So he agreed in principle, and will shortly we'll let you know the final date of hackathon. So before that, a very important hackathon, that is final hackathon, we want to once again sensitize all of you about all the platforms, including the latest versions of the platform, whether it is IBM Cloud, SKD, or any other cloud. There are today there will be three resource persons from Q Krishi and Q Labs, Q Brain, as well as Q Tech. So these resource persons will deal upon different initiatives, different platforms. Before that, I would like to request the regional spots. Please confirm that with all the final participants, final hackathon participants are present with you or not. Sri Bhagavati Mahila Dr. J. Surya Kumar Garu, please respond if you are online. JLTU Anantapuram, Professor Shravabindu Madam, please respond. From the Nikala Institute of Engineering and Technology, Dr. Madhukant Ravi Garu, please respond. In Gayatri Vijayapakshat College of Engineering, Vishakhapatnam, Dr. Anuradha Madam, please respond. Sir KR Vijay College, Bhimavaram, Dr. P. Ravikiran, please respond. And from these 6 regional centers, I also request the participants from Tamil Nadu, Maharashtra, Rajasthan, Karnataka, Telangana, please do respond whether your participants or students are also there and the participants are, because it is going to be very important training activity. So before commencing the training, I also request uh, um, that we have circulated 2-3 proceedings from APSHE to establish quantum innovation centers. These quantum innovation centers are highly needed because immediately after hackathon, we are going to arrange a series of training programs again. Not only that, the final hackathon winners, we will select them for a tour to the hubs across India. Say, for example, there is we are planning to send the final winners to IBM Bangalore. Like this, we are also going to arrange a tour program for these winners for the super conducting qubits. And there are so many startup companies apart from this. You are lucky as the first batch of friends who are training on this quantum platforms. So I appreciate all the folks, all the mentors across the colleges for arranging such a wonderful online program and mentoring you all. Apart from that, around 50,000 students are also now training on Wiser. Apart from this, we are shortly going to NPTEL is shortly going to commence another program on basics of fundamentals of quantum technologies, quantum algorithms, and QuickSet from 19 onwards. I request all the Sparks to ensure that all students must be enrolled in this NPTEL program also. And definitely during this valedictory address, our Honorable Chairman, Professor K. Madhumurthy Garu, actually this is his vision to organize all such things, and he will be joining during the valedictory. And definitely he will announce some of the swaps for you as incentives regarding internships, the credit transfers, and placements opportunities, career counseling, etc. There are so many initiatives that are in store. So many incentives are in store from on behalf of AppShare in collaboration with IBM, in collaboration with NPM, DST, in collaboration with TCS, in collaboration with the CDAC, in collaboration with IIT Madras, MNIT, Jaipur, and so many other institutes are collaborating with AppShare and to help you all. And definitely, I hope and I wish that who are excelling in these aspects, who are excelling in these platforms, definitely will get a first kind of job, a very important job at Amaravati Quantum itself. I once again call upon Dr. J. Surya Kumar Garu, Shravabindu Madam, Madhukant Garu, Anuradha Madam, Ravikiran, and other spots across India to ensure that all your participants, all your students are there, and please uh, assemble them before I invite the today's resource persons. So as you all know that we are ready with so many initiatives for the final hackathon. As per our request, you have to prepare and send the papers to be published, and on the day we are keeping the photograph. We are arranging ID cards exclusively for the final hackathon. So you please bring your ID card. We have already printed your names, your registration, your regulation, everything on these cards. I request both spots as well as the students, please bring your stamps and color photographs so that you can simply paste the photograph on your ID card to ID card. So it should be hackathon should be definitely an outcome based one. So we are expecting there may be at least 10 to 15 jury members, the experts in the quantum computing, quantum technologies, quantum algorithms. So they will ask for your problem statements, your presentation. We have already shared the template. So based on template you have to prepare this presentation. So it is like this: is the abstract introduction, problem statement, literacy review, methodology and approach. Prototype develop. If you have developed any prototype, you have to show the prototype development, implementation, the finally the results and outcomes. What is the innovation and novelty, and any use case and use case applications are there, and any limitations and future work you have to display, and finally the conclusion, acknowledgements and references. This is a template we have already shared for your presentation. Apart from this, you have to on your laptop, including the any kind of online platform, whether it is AWS Cloud or Qiskit or QPride, etc. So anyway, the today's resource person will deal on this. So we are expecting definitely wonderful use case applications and also prototypes. It is responsible to the SPOC of the concerned college to bring your students and keep them in a very discipline. We are also providing you entire set of costumes, that is a t-shirt, cap, and bag, where we can keep and display it, and it's going to be a wonderful outcome-based live hackathon where the experts across India, across organizations like IBM, hubs, quantum hubs will be joining, and in the presence of honorable, in the presence of honorable chairman and the galaxy of experts, you will be displaying your intellect and your softwares, your prototypes, your use cases. So with this briefing, I hope you all understand the seriousness and the very important innovative approach of this hackathon. And now, if any issues are there, you please let me know. And you also WhatsApp me. I hope all the participants across the students are there, and now you are ready with your laptops. Now I may request the students resource persons. Yeah, yeah. Can you? Uh, we will make you the presenter. You can join in the practice. Yeah, yeah. You will. Short message. Short message.
యూట్యూబ్ చూడలేదు
అందరికి వచ్చేసి ఓకే I will cover. Now your phone, you can access your chart.
No, am I audible?
You're audible, sir. You're audible.
Yeah, I think
You have all of
that
those
is not accessible still.
access of laptop, sir.
Actually, can you make it like available for all students so they can also, if they have some question, they can type in or they can.
We can make it, but I think we can manage them.
Hmm.
Okay, okay. I request all the sports players ensure that only once a resource person uh, announces, they have to check out and they have to post them. Otherwise, it will you cannot manage them. I request
Okay,
humbly,
okay.
it's my humble request to all the staff.
Yeah. Should I start?
Yeah, please go ahead.
Yeah. So, hello everyone. I hope you remember me. I have taken one session of yours in the initial, and we explored a little bit of fundamentals. I see a lot of students here, so all of you are like, all of you guys are final participants of this. Like, all of the teams here present are the final selected teams for a hackathon. Is it right? Yeah, sir. Anil sir.
No, sir. Not all.
Hmm.
But we have selected 700 students. So they, apart from the 700 students, we also invited others because they
Okay, okay, sure, sure, sure. Nice,
Actually,
nice.
what final experiment will be with laptops. They will take your instructions.
Okay, okay, got it. Good, good.
Students, they don't have laptops, they cannot do.
So, guys, basically, like today's session is not about I'm teaching you something, or it's not about like I'm talking about some algorithms to you, how you should solve this, how should you approach some problems. Yeah, like just to for a particular hackathon or particular getting some results or something like that. So today is something different. Today we are exploring like how you can make your projects, whatever you are doing, like for this hackathon, apart from this hackathon, into a real use case, or like you can start to see like how you can convert this into research papers and all. So I'll just share my PPT. Just a second. You'll have some references. Let me know if my screen is visible, all of you. Like anybody can answer. Yeah, great.
Yes, sir, it is visible. It is visible. Your audio is also audible.
Great, great. So let's start. So what we'll see today, like if the like what changes at final round, because I think like yeah, you have passed with multiple rounds right now, and like you have most of you have already meet the requirements what your title says. But now what you should do different? How should you something useful, something value added, and how we can make it to some research grade or something like that. So from we'll see like what changes at final round from demo to real world use cases, hands-on modeling and system realism, and what make a project strong and defensible. Okay, so you already have, I think these 10 topics are there, and most of you have already done like the basic requirements. You might have got some solutions, like for example if anybody is doing QML, so you might have got some model with you right now. Okay, with the data pre-processing you have done, you have applied a QML or you have applied ML and added a quantum layer to it, and you have got some results. Similarly, like let's say in portfolio optimization kind of methods, might have used QAOA, got some results out of it. Okay, but now what is the results? Now we need to think in certainly in different way. Like whatever the results you got, does that matter? Okay, is it good, or is it something useful to somebody? Okay, there are four layers right now if we talk about use cases and all. Okay, so like there is layer one. We talk about algorithms that you have already done. Okay, so we'll not talk about getting what we can say uh, what how to apply QAA, or how will you get some good results applying QAA and all. You have explored more than enough right now about it. Okay, so layer two is like so what are constraints and assumptions? Basically, whenever you try to solve a real kind of problem, okay, so there are some constraints involved. Okay, and a lot of assumptions we make. So I'll show you some practical demo. Is my voice clear? I'm seeing some messages. So is my voice clear or proper? Okay, okay. So this layer two about constraints and assumptions. So for example, like when you are trying to solve a portfolio optimization problem, so you try to take more and more realistic constraints. Like cardinality constraint means I want certain number of stocks selected, which will explore little more. So for example, if you take QML, let's say this financial related like credit card fraud detection. So if you try to solve that kind of problem, what kind of constraint might be there? Accuracy, yes, definitely it is there, recall, precision, and all. But apart from that, when you want it to be a use case, when you want it to be something called as production grade, you'll try to go for things such as latency. Okay, is this able to integrate in real what we can say environment? Is it able to deploy in certain system whatever the model you are creating after you reach certain accuracy? So latency, the speed of the your model, how fast it is able to detect some algorithms. So that comes to layer three backend and system realism and use case and narratives. Who is using whatever you are doing right now? So is who is the if you want to make this as a use case, whatever the project is, apart from this, all the 10 projects as well. So think from a user perspective. Whatever you are trying to solve or whatever you're trying to do of it. For example, if you're doing medical imaging, if you're trying to solve medical imaging or something like that, so who is the main user? Okay. Or if you're trying to solve portfolio optimization for some banks, who is the main user? Okay, maybe like if you're going for B2C, so if there is a customer, there is some app, so who is the end user? Like you, the people. Okay. Or if you're doing for bank, the portfolio manager, bank manager, fund manager or something like that is the end user. Okay. So what kind of end user does want there? So if you think from that perspective, you'll get some realistic, you'll get more and more how you can elevate it to use case for industry, for startups, even if you want to go for any startup or something like that. So now I'll share some notebook to you guys. Just a second. Yeah, yeah. So a lot of you guys must be aware about the portfolio optimization, right? And most of you might have solved it as well. So I'll take this example to explain what are the different type of constraint. We'll go minimalistic only. I'll not go in certain high level about that. Okay. So basically, when you're trying to solve such kind of problems, so right now here we'll fix the objective, maximize the returns. Okay. We'll have a data set. Okay. I'll try to fetch a data set from a thing called as Y Finance. Okay. So what is Y Finance? Tool like Yahoo Finance and all, which has all finance related data, and we can download some closing prices. Okay, like the day closing prices from all the year. It stores all the historical data. Okay. So, and we'll try to solve this. I'll try to build this as a cubo. Okay. And I'll try to solve this using simulated annealing. So why simulated annealing? Because this format works everywhere. Okay. You can solve the same thing using, classical solver. You can solve the same using quantum annealers. You might have come across D waves and all. You can solve using the same CIM, the confluence system, hybrid solvers. Okay. And digital annealer like Fujitsu and all as well. Okay. So it's all about, and you can solve the same thing using gate based IBM quantum computer. You just need to map it to Ising Hamiltonian. You need to map this cubo to Ising Hamiltonian. So few you need to map this cubo to Ising Hamiltonian. So few maybe like what words I am using maybe a little heavy for you, but I'm assuming that this session is intended to the final hackathon students, so I'm deliberately using direct terms instead of directly going to explain. Basically, if you see here what I have done in this portfolio optimization, and why I choose this topic, because I think a lot of students or a lot of people attending here are doing investing in their phone, so they can relate it more, right? So basically, like these are some libraries that I've imported. Okay, then I explained to you what is Y Finance. So now what I do, I from Y Finance I take some stock sector. So what is this? This is a stock, and this is a tech sector. Okay, so like stock and its sector. So MSFT again, take Microsoft, tech, Tech, JP Morgan, like Finance, GS, Finance, J&J Healthcare, PFE Healthcare, XOM Energy, and CVX Energy. So basically, now I have a pool of certain stocks. I have a set of certain stocks which are from different sectors. Okay, which are like I think 8, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 stocks with different sectors, right? Yeah. Yeah, 9 stocks with 1, 2, 3, 4 different sectors. Okay, so I try to download this data. from the like Y Finance itself, and I calculate returns, I calculate covariance matrix, and then we build this cubo. Okay. Huh. So when I just a second. Yeah, sorry. So when I try to build this cubo, the first I calculate some returns, covariance matrix, and I build this cubo. So a lot of students might who are trying to solve such kind of problems might be aware what kind of cubo it is, what we're trying to build. And after building and defining this cubo, I'm okay. One thing like you might become like confusing a little bit about we are trying to maximize returns, right? So we are getting this negative mu, okay, because cubo suppresses, cubo gives us the minimize result, right? So that's why I've used this minus sign here. Then this I'm trying to add some cardinality constraint here, which I explained. So what is a cardinality constraint? I want to select exact same some defined number of stocks. Okay, I don't want to have more and more stocks in my portfolio. Okay, so whenever you invest somewhere, whenever you use different kind of platform like Grow, Angel, I don't know what platform you might be using. So whenever you're trying to use such kind of platforms and you try to invest in some stocks today, so it is always defined number of stocks. You don't invest in like, okay, this is growing, let's invest here. You have some limitations, right? You have limitations like you have some budget, you have to select to track the progress properly, to monitor. You need to select in certain number of stocks, okay, according to your flexibility. So like this is a cardinality constraint that does that. So there is sector constraint. So you don't want to invest in each what you can say every money of yours in a single sector. Let's say why such kind of things. Okay, let's say if you use your whole money into, let's say, healthcare or IT sector, and you got to know that is like it's falling down, the market of IT is going down. So what will happen to your money? What will happen to your portfolio value? Okay, so it's like completely values crashing because all of your money is invested in only one sector. Okay, so this is not the ideal case that you must be going, right? And then there is risk limit, like the basically how much risk you want to take. Okay, so uh, this solver, okay, basically these are the three constraints that I've added. And now let's see, I'm trying to solve using simulated annealing. There are some steps, okay, I have defined like 4,000 steps, try to solve it. And the I have will toggle the constraint and understand like how it, what we can say, affect the solution quality. Okay, and what is the k is equal to 4? So this is 9, right? A pool of 9 stocks. So I'll try to set some number here. Okay, so for example, I just wanted to have a 4 stock, and if you are seeing here, so I have defined it as false, any of these constraints that I have defined here. Okay, and I'll try to solve here. Okay, so all this data is downloaded. You're seeing 9 of 9 completed. All this data in real time, it is downloaded from Y Finance library. Okay. And the asset that it is selected right is too high here. Okay. It may be a minus sign, but energy is quite high here. So like it has selected 1, 2, 3, 4, 5, 6, 7, 8. So total out of 9, it has selected 8 stocks. Okay, so is this a good solution? Is it a controlled solution, or is it the solution that you will see, you will accept, and you will invest based on this? No. Why? Because it's just trying to give us a random solution based on what we have got. It is not looking for constraints like risk. It is not looking. So this is so risky solution. Okay, invest in like everything. So it is not adhering like like whether you should invest in proper strategical manner or not. Okay, so let's see if I make this true right now. What happens? Okay, now instead of 8 stocks, I have 4 stocks. And how it set it this up is like now finance we have sector breakdown, like from finance we have two, like JPM and GS. from healthcare I have one, and from tech sector Google I have one. Okay, what does this mean? So it is adhering this kind of constraint called as cardinality constraint. Okay, and why this is important? Because I can at the same time I can just monitor four. Like if I want to manual monitoring with how what things is look for the news of it, I need to like continuously get invested in that company and see what the projects they are doing and all. So basically, like these four are been selected, and it try again like in the cubo we have tried to get maximum what we can say returns out of it. So we are selecting in that. What if I try to now import this sector? What it will do, like if there are same thing from two sector, it try to do what we can say it try to penalize. So now it will have a what we can say sector constraint aware thing. Okay, now see what it has done. Okay, so like Google, uh, from each sector. Last time there was no energy sector here. Okay, now what it has done, it has taken included energy sector here as well. So each thing is there from all the sectors. Okay, so when I try to make it true, now we'll try to minimize the risk as well. Okay, there is certain risk you not take. So if I make this true, yeah. So now this is like it is adhering the risk. Okay, it is trying to adhere the penalties and cardinality, everything that we have, all and giving give us the best result that we have. And you are seeing from the first energy, which was like very high, zero minus 0.0 something. Now it is minus 48, which is much lower than what we had the first time, right? So you can say that whenever you're trying to think with what we can say such kind of problems, always think about what constraints matters the most. So I want you to think in that perspective, like what constraint matter the most. Okay, so just I think chat section is active. So like you, most of you maybe portfolio investing must have their portfolio somewhere, teachers, students, everyone. So can you just chat here, like what kind of real constraints do you think in a portfolio optimization kind may have it? Like just try to type in here, or you can answer to your teacher. They'll type it for you. So like what kind of real constraints does the you know a portfolio optimization software may have, or a solution may have? Like three of you, the three you just got to see, risk, cardinality, sector. So what can be it doesn't need to be like a right answer or wrong answer. It just like whatever you think. Let's take a 2 minute and try to answer this. Like seeing any messages here, I think. No. Okay, I think students are not allowed to send the messages. Okay, they're turned off it, right? Okay, let it be. Uh, so basic, I'll just give an over what can be done. So basically, there is something called as budget constraint. So what is budget constraint? Like you are trying to what we can say, you have certain budget, right? You are not having unlimited amount of money. So like basically you have 1 lakh, 2 lakh, 4 lakh, whatever the budget is, you are trying to solve for it. Okay. So for this budget, you want it as a constraint. Okay. You want your portfolio to be diverse. Okay. So there is a constraint called as diversification. Okay, so there are certain set of constraints that you consider here. Similarly, in your projects, okay, whatever you guys are doing, whatever it is, like QML, Cubo, uh, what I can say, anomaly detection, whatever it is, they just think if you want it to have a what you can say, to make it as a use case, you want it to like take it as a product or something like this thing. What type of constraints are you trying to solve? Here I assume there is like unlimited budget. So what kind of assumption did I make here? I didn't included any budget here. It is just a stock selection, right? So whether can this thing can buy us using the budget, can it buy it? Okay, so I want a good allocation. So this is also like whatever you are buying it should have an optimal allocation. Okay, and you should use all the money that you have. It's not like you have 1 lakh rupees and it is allocating only 50,000 rupees, this kind of algorithm of yours. So these all constraints should be understand if you want to make it as a use case in the industry ready case. So the best way is to like list it down. We'll like discuss it again. I'll go back, jump back to the PPT, or I'll jump back to another module. So most of you guys must be using I think, just a second. So most of, okay, another thing I want to mention which will be helpful for research as well as production thing. So most of you I am seeing like quite teachers are also there, and so this will be helpful for you guys as well. So basically, you must be now, a lot of you guys must be involved with Qiskit, right? So you're using Qiskit for your projects and all. So uh, for example, I'm using a simple Hadamard gate, okay, and I'm using a state vector here. So I have a probability of 0.5, 0.5. Okay, so this is an ideal situation. Similarly, if this is a state vector, it gives us an exact value. Okay, but same thing. Okay, I'm using same thing, but I'm now using a sampling short based simulator. Okay, so instead of getting an exact state vector mathematical value, I'm trying to do is in a short based. Okay, I try to run it 1024 times and I get some counts. Okay, and by that counts I get a probability. So if you are seeing, ideally it should have like some final because of the 50% probability. But you are seeing like these shots. Okay, so the zeros are 505 and one is like 519. So here you can see like when you're trying to base something called as sampling, because in IBM quantum setup or any neutral atom or anything other you are trying to go, so this is something that you use generally, okay, for any solution. So you get the highest probability of a solution. Okay, so this is a distribution here. So this is close to 50-50, but not exactly 50-50, which is supposed mathematically and theoretically, which is supposed to be. So this is one how you get a little solutions here. But now what I do, this is again ideal. Okay, we are doing this as a sampling base, we are measuring like a lot of times, but again this is ideal. Okay, so pay attention here. Like what in the actual hardware right now, currently all over the globe, it is dominated by noise. You must be hearing like you have listened to talk of L Venkat sir, right? L Venkat Subramaniam sir is insisting like this is noise is there after a certain time like 2030, 2032, or next year they are trying to take some important step, okay, to counter use this noise, okay, and get rid of the noise issue and all. So today's hardware is like noisy hardware. Okay, so whatever you try to do, uh, it is dominated by noise. Whatever your jobs you submit there, you try to run. Okay, unless you try to do error mitigation, again error separations and all. Also, even using such kind of techniques, you're not getting. So we'll just see an example here. I'm trying to formulate a Bell state. Okay, a simple circuit. Everyone who has done the fundamentals knows what is a bell state is. So like I try to add a depolarizing error here. Okay. And ideally, what should have been happen? Okay. It is a maximally entangled state. Okay. So what should have been there? Like 1 1 and 0 0. Okay. But when I add this noise, okay, just see this graph. What is happening? It's not, exactly destroying some structure, it's breaking some algorithm or something. But now, because of noise, okay, because in ideal state right now, what I'm running, it gives me like, okay, these are the only like solutions that I must look for: 0 0 and 1 1. Theoretically, it is a maximally entangled state, so this is the right answer, the blue bar you are seeing. But noise also gave us 22 counts and 27 counts, like 22 counts of 0 1 and 1 0, like 27 counts. So it means that noise is making me less reliable for this kind of solutions. Okay. And here comes the part that is called as, error mitigation, like a lot of good area of research, like research area of interest of a lot of people. Like, so today's hardware is noisy. How you can make, like, suppress this? How you can correct this? Okay, how you can make that whenever you are running the algorithm on hardware, these two bars, in other words, this too small, don't want it here. Okay, when the noise is there, I don't want these two bars here. I want it like in the 1 1 and 0 zeros. Okay, so this is something you will relate to, use case as well and research as well, because a lot of research is going on similarly in India. Like a lot of people are there. For example, Prabha Mandem is doing a research in, I think, error correction and all. And when you do this, so also that it takes to a step further, like people are interested in logical qubits as well. So these are like error because right now you're seeing like 127 qubits quantum computer, so most of them are like, physical qubits, whether it is neutral atom and all. Okay, but you don't need error in all of this here. You need a controlled environment, right? So stop sharing just a second. Okay. So just a second. I think my screen again stopped, right? Just a second, I'll share again. So I think now it might be visible, yeah. So whatever you did so far in your hackathon project, or whatever projects you're doing, maybe like for your capstone, undergrad, or whatever it is, okay, is something what you show in this hackathon. It works in ideal settings. Assumption are hidden. Like for example, I assume the budget in that portfolio. Okay, focuses on correctness. Like, okay, this is the good solution. Optimize for presentation. Okay, and it looks impressive. Like, okay, this is giving so and so solution. But whenever you are trying to convert into use case, so Apshi wanted it to be have focus on how you can make this use case. Okay, so realistic constraints. Okay, assumption are explicit. Whatever you are assuming, okay, they're completely explicit. You are not underlying any assumption that that you are not aware of, or by mistake you are doing. You are properly aware of your environment that you are building, right? It should be reliable. Okay, optimize for real decisions and accepts its limitation, what it can do, what it cannot do. A perfect use case, whatever you're trying to build, you should be completely aware of it. Okay, its strengths, its weaknesses, its capability, okay, its reliability and everything. Okay, then what are some common pitfalls? Okay, so some common pitfalls in this okay, I'll just go back. I think some students are trying to take some photos. So yeah, I think a lot of you are done. So some common pitfalls in this quantum project. Uh, so claiming advantage from ideal simulators. So you saw like these ideal simulators are just like you know uh, they are not showing us what is happening on actual hardware. We want the solutions to be run on actual hardware, right? So ideal simulators is not a good thing to go. Okay, even like for research it is just a toy thing. If you are just see like whatever your approach is, final end thing is, according to it what suits the best. Like are you requiring more and more qubits? So is the ideal simulator good for you? No. Then go for the, what you can say, noise based simulators. Okay, so you go for noisy QSM. Okay, like ignoring constraints for better results. So maybe like, if you're thinking, oh, I'm not getting a solution, I'm not get if I injected sector diversification, okay, if I injected allocation of money, I'm diverse allocation of money, a perfect allocation of money, I'm not getting, what you can say, better results. Okay, I'm not getting good results. So you are just removing it for the sake of that. So you should not do it. Okay, because it's not this algorithm, whatever you are developing, it's not helping anyone in that sense. Okay, for research and further things, most even for the classical thing or quantum projects, what you are doing, the most important thing is baseline comparison. So if you're not doing baseline comparisons, okay, what is baseline? Like for example, you have developed a quantum algorithm to solve, let's say, this portfolio, but are you classical algorithms? Okay, whatever, like supply chain problem, routing problem. Okay, ML, if you're trying to solve QML, are you comparing your solution with ML? Is it really something called as advantageous, or you just did some QML and it has low accuracy and you're some claiming that I have done some kind of project? So it's useless there. So the most like it's not like, you just chase again like for advantage in the first hand, but whatever you are doing, it must be useful, because it not because it just quantum, it should be giving better results. You should use quantum in a such a way, either hybrid or full quantum, that it gives you better advantage than what classical are not capable of doing. That's what we are going in the quantum domain. So always have a baseline comparison. And don't hide any instability, limitations, or weaknesses. Whatever you are, try to work on the limitations or weaknesses. Whatever you are, try to work on them. Okay, to make this quantum taking to any industries and all. Whatever you do, like even if you want to get, let's say, if you want to get placed in good companies and all, so this is something like ideal for any kind of projects. If you want to take it a step for githubs, you'll get recognized by there. So like not only this quantum computing companies, but if you're targeting something like software engineering roles and everything, try to do some because people will see how realistically you have thought about this. Okay, people will you can when you are going for interviews, you can claim this, see, I have done this. Okay, if they are relevant, let's say like JP Morgan doing some financial project, it is more relevant to them like what you are doing. So they are getting impressed by you. Okay, by your by your resume, you are thought in that sense. Okay, so try to always don't stop, don't do lot of projects, do some selected projects, but take it a level further. Okay, take it a step further than the some common threshold. So what you learn today, like constraint define realism. Okay, um, always same algorithm you're using in the ideal situation may not give others are lacking of. Okay, if you think you are hitting some dead end or not, others are lacking of. Okay, if you think you are hitting some dead end or not. Okay, so what breaks when the assumptions is removed? Okay, so let's say if you're knowingly doing some assumption. Okay, and one more thing, whenever you try to do some projects, so they are what I can say, unknowingly or knowingly you make some assumptions. So always try to list that and do something. Just try to list that and do something. And okay, so for research paper, okay, try to go for sensitivity analysis, stability versus performance, as I've taught, and most important, comparative baselines. Okay, So I think we are running out of time. So I'll just end with this quote: good research starts where ideal demos stop. Okay. So thank you all of you. And yeah. So all the best for you guys for final hackathon. All the best for your capstone, or all the projects that you're trying to do. Make some selective, not go chase behind like a lot of many projects. Take selective projects, take it some step ahead further. And all the best to all of you guys. Yeah. Thank you.
Hello? Well, I'm quantum mechanics, SKT documentation, etc. The discrete machine learning version 0.20.0 to 0.90. Thank you very much for your to 0.90. Thank you very much for your contribution. Contribution really it will be helpful to all our students. Uh, uh, Once again, I thank you for sparing your time. On behalf of Akshay, I thank you profusely, sir. Thank you.
Thank you.
Thank you, sir. Now I request Prithvi and Prithvi from